Hello students, welcome to Unit 5 Notes, Section 7.1. I already did the warm-up for you, so you can pause the video now and try this out. If you continue, here is one little note here. You'll notice I wrote 10 over 10 as 1 over 1 instead of just the number 1. The reason for this, the directions are asking you to simplify each ratio. In ratios, you don't normally just use the number 1 or the number 2. You normally say 1 to 1, 1 to 2, 2 to 1, kind of like your Google Chromebooks. We are considered to be a 1-to-1 school because for every one student, there is one Chromebook. Therefore, if there are 10 students, there are 10 Chromebooks, and so on. So we want to write this as 1-to-1, not just the number 1. Even though I know 10 divided by 10 is 1, we are simply writing it as a ratio. Here are two other ways to write ratios besides just fractions. We can write it with a colon, so 2 to 3. In this case, 8 to 2 is 4 to 1, written out with the word 2. So these are just a couple different ways of writing them. All right, so this lesson should be pretty quick. It's on ratios and proportions. We're going to write ratios and solve proportions. A proportion is when we set a ratio equal to another ratio. So for instance, here's a ratio. It is, let's write 1 to 2. And here's another ratio. There's another ratio. Oops. And when we put them together with an equal sign, that's what makes a proportion. So it's when we set two ratios equal to each other. So it can be read as A colon B, which is the ratio of A to B. All right, here's some vocabulary for today: ratio, proportion, extended proportion, which is, this is an extended proportion. A is to B as C is to D as E is to F. So it's when we do more than just one equal sign. Cross product property, which you're probably familiar with, which is when we do A over B equals C over D, and we actually find the cross products. Let's see, let's write this a little bit larger. So in this case, A times D is AD. That must be equivalent to B times C. It's hard to tell what that is when I do that, which is BC. All right, and that's the cross product property. Scale drawing, we're going to look at drawings and look at their scale factor. Scale and scale factor. You might want to add the word factor to this. Scale factor. So a ratio is a comparison of two quantities. You can write the ratio A to B, or the quotient A to B, as long as B doesn't equal 0 in the quotient or in any one of these. Unless otherwise stated, the terms and expressions appearing in ratios in this book are assumed to be non-zero. So here's a proportion statement. Again, it's rewritten. You can write it. We're going to write them as fractions. So let's just circle this. We're going to write them as fractions. We're not going to necessarily represent them like this, but I've seen on practice SATs. So this is SAT style sometimes, not always, but I often see them on like practice SATs like that. There's an example of an extended proportion here, which I wrote above, and then here are some properties. So if you were to, for instance, find the cross products, those cross products are equal. Here's another thing you can do. You can flip the fraction and flip the fraction. So if you flip the left and flip the right, that's also equivalent. Okay, so if you have like 1 over 2 equals 3 over 6. That's the same as 2 over 1, which is 6 over 3. Here's what's really, really cool as well. Because you have the cross product property, which means B times C and A times D, you can actually flip where if you have A and D, you can flip B and C. You can actually flip A and D as well, because no matter what, you're multiplying them, so the order of multiplication does not matter. On the diagonal, I mean. So it doesn't matter if you do A times D or D times A. That is totally okay. It doesn't matter where these go on the diagonal. However, you can't just switch one side. You can't just flip B and D without flipping A and C. And you can't just move C somewhere, like you can't just move C over here and then A down. It doesn't work that way, but you can switch the diagonal. And here's an example. So like if I had 1 over 2 equals 4 over 8, I can just switch the 4 and the 2. So take a look at this. So 1 over 4 equals 2 over 8. Because on the diagonal, no matter what, 4 and 2 can go wherever they want. Same thing with 1 and 8. All right. And then this last one is, if you have A over B equals C over D, you're actually able to add B to it and D to it, which is the denominator. Why is that? Well, think about this. If you split this up, you would have A over B plus B over B equals C over D plus D over D. And D over D is 1 and B over B is 1. So really you're just adding the number 1 to both sides. It's nothing crazy here. Like if I have 3/4 and 6/8, I'm allowed to add 4/4. I didn't really space that out well enough. Okay, not what I wanted. Let's try that again. If you have 3/4 equals 6/8, you're able to add 4/4, which is really 3 plus 4 over 4, and you're able to add 8/8, which is, both of these are just the number 1, so you get 6 plus 8 over 8. That's a legal operation that you're allowed to do, is add the number 1 to both sides in the form of a denominator over a numerator over denominator that's equivalent. Okay, so multiplying both sides of this is the cross product property. You may state the property, yep, the product of the extremes is equal to the product of the means. There's your means, there's your extremes, and there you go. So let's do we have a couple of examples. The first one is a real world one. The photo that is 8 inches wide and 5 1/3 inches high is enlarged to a poster that is 2 feet wide and 1 1/3 feet high. What is the ratio of the width of the photo to the width of the poster? So we want to find out what the width, the ratio is. So we want to be careful here. We want to either make these inches into feet or these feet into inches. And I think it's going to be easier to make feet into inches because I'd rather multiply than divide, right? Because 8 over 12 isn't too bad, but 5 1/3 over 12, can get a little bit tricky. So what I think I'm going to do is I'm going to take this, I'm going to say 2 feet. There are 12 inches in 1 foot. So I'm going to multiply that together. Whoops. When I multiply that together, feet over feet goes away, and I get 24 inches. 1 doesn't matter either. 24 inches over 1. So we got 24 inches, and then the second one I'm going to do is 1 1/3. So I'm going to call that 4/3 feet. I'm going to multiply that by 12 inches because there's 12 inches in a foot. These units of feet will go away. The 1 goes away as well. We don't need that. And this ends up giving me 48/3 inches, which is 16 inches. Let me just check. 1 1/3 times 12, which is 16 inches. Yep, that's correct. So now what we're comparing is 8 and 5 1/3 to 24 and 16. So I'm going to write it like this. This is going to be kind of strange, but bear with me here. I'm going to write 8 inches is to 5 1/3 inches as as 24 inches is to 16 inches. And I'm going to find the cross products. So I'm going to do 8 times 16. I'm going to do 5 1/3 times 24. So I'm going to do 5 1/3 times 24. Wait a minute. You know what? I'm sorry. I don't need to do this. What I do need to do is just compare. My apologies. I'm just comparing. It wants me to, it says, what is it doesn't ask if they are proportional. What I was doing was proving that they were proportional. What it says is, what is the ratio of the width of the photo to the width of the poster? So let's take our widths, which is 2 feet, which is 24, and then 8. So I did a little bit more work than I needed to. So if I have 24 inches, what's the width of the photo? So width of photo compared to the width of the poster. So I'm going to write it in that form. I'm going to write 8 inches over 24 inches. Inches will go away. And so I have 8 to 24, which is 1 to 3. All right, I did a little bit extra work, but I think this is going to ask me that in the next question. So I'm just going to bring that work down over there. So we're going to say, we're going to conclude, what is the ratio? The ratio of the width of the photo to the width of the poster is 1, 2, 3. All right. And now in the next one, it says, what is the ratio of the height of the photo to the height of the poster? And so these are heights. And so we kind of already did the work there. Sorry, I didn't read the problem correctly when we first started it. So we're going to do the height of the photo to the height of the poster. Again, we're going to keep this order right here. All right. And it's not width, it's height. So I'm just going to change this to height. So height of photo to height of poster. And the height of the photo is 5 1/3. Where is it? 5 1/3. And so we're going to do 5 1/3. Yuck. Not the nicest numbers, but that's okay. 5 1/3. And we're going to do, what do we get? Oh, 16. 5 1/3 inches to 16. And that you might not like, but you know what we can do? We can multiply, well, let's see, 5 1/3 is the same as 16 thirds. So it's 16 thirds to 16, which is going to be, it's the same as 16 thirds times 1/16, right? If you want to write it as a fraction over a fraction. So this converts, 16 converts to 16 over 1. 5 1/3 is 15 thirds and 1/3, which is 16 thirds. So I'm going to keep this fraction change from division to multiplication, flip this, and what I end up getting is 1/3. Well, that should happen, right? Because it's the same as the width. The width is a 1:3 ratio, and so are the side lengths. So the ratio, so I'm going to say the ratio of the height of the photo to the height of the poster is 1, 2, 3. Alrighty, that was a real world example. So now we're going on to our properties. So this is just saying it wants us to complete each statement. So the initial statement is x over y equals 5/6. So it appears that they did the cross product property for the first one. Looks like they did x times 6 to get 6x. So now we have to do 5 times y to get 5y. And we are done with that problem. Okay, this next property, it appears that they flipped x and y. So we just have to flip 5 and 6. And we're done with that one. The next one, x over 5. Okay, it looks like it appears that they moved 5 right over here. So if they moved 5 right here, we have to move y right there. So x over 5 is going to be equal to y over 6. And the last one is x plus y over y. So it looks like they added a y up here, which was the denominator. So we're going to have to add a denominator here. So we're going to get 5 plus 6 over y. Oh, wait. Over 6. Because our denominator on the right-hand side is 6. All right? This next problem, write two proportions that are equivalent to m over 4 equals n over 11. So equivalent proportions need to be ratios. So we can't do our cross product property. We have to do something like this, like B, C, and D, but A, we can't do A because asking for it to be a proportion. So what I'm thinking is we can do 4 over m. We can just flip both sides. 11 over n. That's one of them. We can flip n and 4, so we could say m over n equals 4 over 11. We can flip m and 11 if we want, so we'll get 11 over 4 equals n over m. You know what we can do too, this is crazy, but we can actually rotate these items for the last one. You can write it like this. You can move m down, you can move 4 over, you can move 11 up, and you can move n over to the left. And that's true because isn't that just the flip of this one right here, right? So we have a whole bunch of them. It only asked for what? It asked for 2 of them. We wrote 4 of them. We doubled the amount of answer choices here. Okay? All right, solving for a variable. So you're going to use your cross product property to solve for this. So we're going to do, let's see, light purple, red. Let's just change the color of some of these. Blue, green, and purple. All right, so let's do the cross product property for this one. So x times 7 is 7x. 5 times 12 is 60, and divide both sides by 7. So x equals 60 over 7. I don't want to simplify that anymore. I don't want to get a decimal because that would be approximate, and I like this exact value just the way it is, and it's in the form of a ratio. This one, we're going to have to make sure we do the distributive property after we do 4 times y plus 3. We're going to have to distribute that. So we get, 4 times y plus 3 equals 8y. So distribute, we get 4y plus 12 equals 8y. We're going to take 4y away. Doesn't matter how you solve as long as it's legal. We get 12 equals 4y, and we get y equals 3. All right, the next one, we're going to solve this proportion by finding cross products. We get 20z is equal to, looks like it's going to be 15. Divide both sides by 20. This one's a quick one. And so z equals 15 over 20. Now we're going to want to simplify that. So we're going to divide both the numerator and denominator by 5. So we're going to say 3/4. So z is equal to 3/4. We always want to write a ratio in the simplest form possible, which is the most reduced. All right, this last one, we are going to do n plus 6 times 6. Whoa. So 6 times n plus 6. We're going to do 18 times n is 18n. Distribute. So 6n plus 36 equals 18n. Take 6n away. 36 equals 12n. Divided by 12. N equals 3. And that's it. I mean, we can always check our work too. So if we want to check our work, we would do 18 over 3 plus 6 is 9, and 6 over 3, that checks out to be correct. All right, here's another real-world problem. Use a ruler to measure the length of L of the bedroom in a scale drawing. What is the length of the actual bedroom? Let's see, can we do this problem? Use a ruler to measure the length L of the bedroom in the scale drawing. What is the length? So the scale is 1 to 16. Oh, okay, the ruler does show that the length is 7/8 of an inch. So in this case, we have a scale which is 1 inch is to 16 feet. Okay, so one inch equals 16 feet. So I'm going to say that 1 inch is equal to 16 feet. What we measured is a length of 7/8 of an inch. So we're going to do, this is weird, 7/8 of an inch in the numerator, which we don't really like to put fraction over fractions here, but we'll do 7/8 of an inch over x feet, because really what we want to know, what we want to know is how this, how this scale drawing, what is the actual length of the bedroom? Well, that's going to be in feet, right? All 4 of these. Now you're going to say, Mr. Alvarez, Mr. Wright, these right here, how can you compare inches to feet and inches to feet? Well, as long as the numerators are inches and the denominators are feet, or the left-hand side is inches and the right-hand side is feet, or vice versa, we are actually, or feet in the numerators and inches in the denominators, we can actually compare these. Remember in this example, we did convert feet to inches and to compare them, but I'm just going to show you that it actually works if you are consistent, as long as you're consistent. Okay, what we do know is whatever result we get will have to be in feet. So we're going to ignore the cross product of feet and inches because that would give us feet, inches, which aren't really a thing. But as long as we know our result is in feet, and let's check this out. So we're going to do 16 times 7/8. So 16 times 7/8 is equal to 1x. Again, we're going to ignore, or in this case, just x. We're going to ignore this, but our result we know will be in feet. So this is going to be, we do 16 times 7, which is 112 over 8 is equal to x. And when we divide 112 by 8, we get the number 14. So x is equal to 14 feet. And there we go, 14 feet. So the answer is B. Now let's say you don't feel comfortable with converting, if you're like, feet to inch, I would feel more comfortable if I change my feet into inches. That's fine too. Your result will be in inches and then you'll convert it to feet. So let's say we did do that. Let's just say version 2. Let's put version 2. So instead of saying 1 inch is to 16 feet, I'll say 1 inch is equal to 16 times 12, which is 192 inches. So in reality, this is a 1 to 192 ratio. In actual ratio, it's 1 to 192, not 1 to 16. Okay, and so if I want to do this, I'll now do 1 is to 192 as 7/8 is to unknown. Because what I'm comparing is, I'm comparing drawing to actual room scale, and drawing, in this case the ruler, to actual room scale. So it's going to go drawing room, and so now I'm going to do 1 times x is x, and then 192 times 7/8. So 192 times 7/8, which is equal to, times 7 is 1344 over 8, which is equivalent to 168 inches. So now I'm going to do 168 inches times, there's 1 foot in 12 inches. So these units go away. And that will give me 168 feet divided by 12. So divided by 12, which is 14 feet. So either way, we're dealing with, we have to convert our inches back to feet. So I think it was just easier as long as we knew that feet would be the result that we would get. So in both of these, we are good to go with 14.